Hello everyone. So in this session, we are going to discuss one more example for push down automata, that is a power 2n b power n. So this is a bit different one. So the number of a's here are 2 to the power of 1. Like when n value equal to 1, we'll be having 2a followed by 1b. And when n is equal to 2, we'll be having 2 into n, that is 4 a's followed by 2 b's. Okay, and it goes on. So next we'll be having 6a 3b. So all those kind of input that comes under this category will be listed. So here the number of a's are more, it is twice, actually it is not more, twice the number of b's. Okay, but the a's are coming front. So what can be done for this now? Like first step, the idea behind using push down automata is we have stack as a memory unit. First step, put the z0 into stack. And for the next step, for a single a, when you have a single a, push this x into stack and have a state change. So we should have an even number of a's, right? So we can have the states as q0 and q1. So in q0, when you have a single a, I'm going to push the element into stack, and I can have a self loop here. So for the first a, push this x, and the second a, I can have a state change. So for 2 a's, I can have only one x pushed into stack. Okay, so for 2 a's, I'm going to push one x into stack. And the criteria here is for all even number of a's, first a will be pushed in q0 itself, and second a I'm going to q1. And next a, I'll come back here and push this x. And for the next transition, next a, I can move back to this q1 state without changing the element into stack. So when it is an even number of element, I can stay in this state q1. Okay, if you're getting confused, we can have two more states. Okay, so first element can be pushed into stack, and then we can go for the next elements. Okay, for all the even number of a's, we are going to stay in this q1. And once you have b, it is easy, right? For 2 a's, we have pushed only 1x into stack. So when you have a b, cancel 1x. For 1b, 1x will be cancelled. For the next b, next x will be cancelled. At the end of input, if the stack is empty, the input will be accepted. Okay, so that is a category. For 2 number of a's, we are going to push 1x into stack. Okay, so that is the basic idea that I'm going to use here. So you can have your own way of doing it, like it is like programmings, right? So anyone can have their own way of doing this. So this is my ideology. Like when we started the state q0, first step is without consuming any of the input symbol, if the stack is empty, you're going to push the z0 into stack, first step. And second step is, as I told you, when you are scanning the input A, okay, so first step, you have Z0 in the stack that will be popped out. And for this A, what we have to do, we have to push X Z0 into stack. So when the input is A and the topmost element of stack that is popped out is Z0, we are going to push X Z0 into stack. Okay, so Z0 will be occurring only once. So for the first element alone, you will be having Z0 transition. For the next element on, the topmost element of stack will be X. Okay, that cannot be modified. So the next step of transition is, I told you now, for counting the even number, you're going to have a state change. When the next input is A, this topmost element of stack X will be popped out. Okay, so when this X is popped out, for these two A, we are going to have only one X to be pushed into stack. So this X that is popped out will be replaced back into stack. So when the input is A and stack consists of X, the X that is popped out of stack will be replaced back. Okay, now you could have understood, right? For all your even number of A's will be in the state Q1. And now the next step of transition is, listen carefully, for the next A, you're going to repeat the same procedure. For this pair, 1x is popped out, right? So next what happened? The topmost element of stack will be, you'll be having z0 x now. This x that is there will be popped out. Okay, for these two pair of input, I'm going to repeat the same procedure. 1x extra need to be pushed into stack. So this x that is popped out of the stack will be replaced back. Along with that, one extra x will be pushed. Okay, so this is for the next pair. So next pair transition will be written like this. From Q1 to Q0, when the input consists of A and stack consists of X, we are going to push double X into stack. Okay, and the process is repeated. For the next step, what happened when you are scanning the next input, your transition will be from Q0 to Q1, and this X that is popped out will be replaced back. Okay, so it will be at the end of transition. For after scanning 4A's, your stack will have 2X and the transition will be in Q1 state. Okay, so this is how it is going to be repeated. So next, when you scan 2 more A's, 1X will be pushed into stack. So for each 2 A's, 1X will be pushed into stack, and for even number of A's will be remaining in the state Q1. Okay, so now what happened? After pushing all the A's into stack, next comes your cancellation process. Cancellation process is very easy. See what we have done. I'll write the transitions to here, instantaneous description. From the state Q0, when the input is A, B, B, and stack is epsilon, first step what we did, we pushed this 4A is B, we pushed Z0 into stack, and when the input is A and stack consists of Z0, when the input is A and stack consists of Z0, what we did, we stayed in the state Q0 itself, and one input here is removed, and we are going to add 1X into stack. Okay, so for the next step of transition, when the input is A and stack consists of X, the X that is there in the stack will remain as it is. Okay, so this input will be removed and the stack will remain as it is. For 2A's, we are going to push only 1X into stack, but the transition will be moved from Q0 to Q1 state. Okay, so next step of transition, we have the back loop. When your input is A and stack consists of X, we are going to push one extra X into stack and the transition will move from Q0 to Q1. Sorry, Q1 to Q0. So this A will be removed and we are going to have the transition as 1X will be added into stack. Now next step, what happened? Q0, when the input is A and stack consists of X. AX, we are going to have the state change transition here. It moves from Q0 to Q1 and this A will be removed, stack will remain unchanged. Whatever element is there in the stack, that will remain as it is. Okay, so for any even length of string, even length of A's, your transition will make it move to Q1. Okay, so from here on, the transition is going to be easy. What we are going to do, it is cancellation process, right? For each step of transition, we are going to cancel one element out of stack. Okay, so for here, after this place, we can have a state change. It means that all the A's are cancelled off. So we can have a transition to, we have state still Q1, right? So we can make a transition to a new state Q2. In Q2, what we can do, for each B in your input, if there is X in the stack, for this will be cancelled out. You will have epsilon. So for this B and this X will be cancelled out, we'll be going to the state Q2. So in Q2, you're going to repeat the process for all the remaining B's. So I'm going to make a self loop here. For all the B's, you're going to cancel one X out of stack. So for this B, this X will be cancelled. Now in Q2, all the inputs are processed. So you don't have anything here and stack will have X, Z0. In that time, you can make an acceptance state. So acceptance, when you want to accept by empty stack, you can add one more transition Q2 epsilon epsilon. So you can have one more transition if all the inputs are processed. If stack consists of Z0 alone, you pop out the Z0. So at the end of your input, your stack consists of epsilon. All the inputs are popped out. Stack is empty. The input will be accepted. Okay, so this is acceptance by empty stack addition. Or if you want to accept the input by moving to final state, make a transition here to another new state Q3 as a final state. And you can have the transition at the end of your input. If stack consists of Z0, you can either have this Z0 here or X here or epsilon here. That is your wish. But the transition is moved to a final state. So in this space, you can have the transition move to Q3 epsilon comma Z0 or epsilon. Okay, you can have this Z0 itself. So at the end of your input, if your transition move to final state, the input is accepted. So based on the question that is asked for you, if the transition is, if you are asked to construct a push-down automata that accepts by empty stack, you have to follow this transition. If the input has to be accepted by moving to final state, you have to make a transition like this. Okay, so when you have a stack as a memory unit, you should find the way in which first you have to frame your ideology. When you are able to find frame your ideology, like manually work out how it is processing, then you can put everything together and draw a transition diagram like this. Okay, it's like programming. Everyone has their own way of doing it. So this can be done in different ways also. Okay, thank you.